So make sure, please, we go back to 4 rows of 7. Hand up and over your assessments, please. Make sure your note packets are out. What page should we leave off on? 17? 15? All right. Make sure you've got your notes out and open, please, to page 15. Hand those up and over now. Any others? All right, we're going to go right into what our notes are for today. But understand, next time we have class, you have a quiz, and on that quiz, you need to know how to simplify radicals, which means cube roots, square roots, variables, the whole mess. You need to know how to rationalize denominators and multiply multiply radical expressions. If I have like 2 plus 4 root 6 or something like that, and 2 minus 8 root 3, you should be able to go through and multiply those. The next thing that you need to know is how to rationalize a denominator. You do that by multiplying by the conjugate. The next thing that we need you to do is know how to do is solve radical equations. I think there's 5 total. I think that there's 1 simplifying radicals, 2 rationalizing denominators, and maybe 1 or 2 equations. You need to be good at identifying when things are going to simplify out, etc. But that's the stuff that's fair game for your quiz that we have next class. So far, you have 0 grades in the quiz category, so that can be a big opportunity for you to do quite well. Let's bounce over, please, to our notes. We left off, and we're going to talk about today something that you experienced before, and we sort of, previously you had people that sort of shut the whole operation down. Let's take a look. We're solving for this by using a square root method, or using square roots to solve. So to start off with, for 1a, this is what we would go through in half. You've got 5x squared minus 100 is equal to 0. This is going to be a quadratic equation. How many answers, let's remind ourselves, how many answers, Jaron C., how many answers should this question have? 2. You know that because it's quadratic. 9 times out of 10, you're going to get everything over to one side and solve by taking quad factoring, taking the square root sum method. Looking at what's there, since there's no bx term in the middle, Christina W., what would you do to solve this out? You could. I want to do one thing before I divide both sides by 5, though. What's that? Add 100 to both sides. Yeah. So now I've got 5x squared is going to be equal to 100. From here, the next thing that we go through and do now is divide both sides by 5. So I list out x squared is going to be equal to 20. From here, what would our next step be? Nathan? Terrific. Now we get to this point here, and you've got x is going to be equal to, and I'm going to stop us right now. This right now is not an acceptable answer for you. Can anybody tell me why you would expect to get a demerit on your paper for this? Yeah. You need to simplify. What perfect square goes into 20? So what's this now? And by the way, it's okay. I don't need you to show this step out. What will this simplify into? Hands up, please, if you can tell me. Now, when we do this out, I list out x is equal to plus or minus 2 times the square root of 5. Questions on that? You can do that right in your head. That's how good we should be by now. This next one is going to where we encounter something interesting. Maddie, what would your first step be to solve out 2x squared plus 2 is going to be equal to 0? So now I have 2x squared is equal to negative 2. What would we do next from here? Cassie? So you've got x squared is equal to negative 1. Now some of you play it forward. Who can tell me this great new world we're about to encounter? Who can tell me what they see that's going to be awkward about this? Up until today, you have been told that you cannot take the square root of a negative number. And you're right. So what happens in mathematics when we hit an impasse or a roadblock is we find a way around it. So what we're going to do instead is, instead of saying, I give up, it can't ever happen, what we're going to say is this. I'm going to make a new perfect square. And I know the square root of -1 is now equal to the imaginary unit I. So the square root of -1 is a perfect square. You know 4 is a perfect square, 9 is a perfect square, 1, 16, 36, 324, all of these are perfect squares. So is the square root of -1. So I take the square root of both sides, and I get x is equal to I. Are we okay with that? Yes or no? Just like sheep. Who here is going to tell me I'm wrong? Go right ahead. What? How many answers are we supposed to have? 2. Keep that in your mind the whole time. It's plus or minus I. Don't forget the little things as we're doing them. Now, yes?
Why is it I?
We're making, because we hit that impasse?
It's just any random number.
No, it's the imaginary unit I. And we're assigning it that value. It's not like the number pi, where it actually comes from a ratio. The number I, we actually hit a roadblock and said, you know what? We can't go forward unless we solve this. And everyone's going, God, if only we had this one key that could open it up. So instead of sitting there going, does it exist? Maybe. We said, fine, we'll make it exist, and then we'll adjust ourselves accordingly. But all of the regular rules of algebra still apply. And we're going to get into some fascinating stuff when it comes to I, in terms of graphing out. If you have a question. What we'll say is this. There's no real number. Up until today, you've only worked with real numbers. Real numbers are actual tangible amounts that you can have. Like the square root of 5 isn't a clean, easy number, but it's a real number. You could imagine square root of 5 would give you whatever that value is, 2 and some change. Now we're working with something that we don't have an actual value of for it. But we know that if we use this unit, all of a sudden the problem area that we have goes away. It literally is an imaginary unit. You can't have I number of apples. You can have 4 apples. You can't have 4 I apples. Okay? And that allows us to get around that sort of wall that was blocking us off before. You need to remember what I is defined as. So we're going to say this, the imaginary unit, which is I, is represented by this. Now I'm going to list out this. I is equal to the square root of -1. You've got to know that. And there's some really beautiful equations. There's an Euler equation. I can't remember if this is it. You all haven't even worked with the number E yet, is that right? Okay. There's a number E. I think if you take E to the I pi power, it equals -1. Okay? I don't know if that's, but we'll look it up. We'll look it up. I don't want to have you write it down. But that's something that goes through and happens. Now, what we need you to be able to focus on, though, is the math that you can do. So let's do this right now. We'll show you it later, but we're going to evaluate now the wheel of I. I is cyclical. You'll see when we raise I to different powers, and we're going to handle a bunch in the beginning. Everything else goes off. What do I get if I take, and again, you all are capable at this point of answering this question and filling all of these values in entirely. What is I to the 0 power going to give you? Hands up, please, if you can tell me. We got 1, 2. This is not an extension. What do you want to say? No. 1. Anything to the 0 power, any base to the 0 power is going to give you 1. I to the first power is just going to leave us with an I. I to the first power is I. Now we need to know what I squared is. Think about what I itself is. What do I get if I take and square that? So what would I squared be equal to? We've got 1. 2 of you that can tell me? -1. Why is it equal to -1? There you go. Now this is the toughest one. Is I to the third. Does anybody know what I to the third would be? How? Oh, that's it. That's one way of doing it. I'll show out what you're talking about. 1 second. I did this. Isn't I squared, I to the third the same as I squared times I, because you add the exponents? Well, what's I squared equal to? -1 times I to the first, which would be I. What you're saying to do, what Nathan's saying, is I to the third is equal to the square root of -1 times the square root of -1 times the square root of -1. What do I get if I multiply those first two together? -1 times, what's the square root of -1? I. So either case, that's the justification for it. I'm not telling you you need to memorize out the justification, but you should be able to generate this piece. Now, there's one more thing I want to give you to write down, and then we're going to do some evaluations. When you list out, these are called complex numbers, and they're written in A plus BI form, where A and B are real numbers. This is called the real component, and this is called the imaginary component. Every single number that you've listed out so far in your entire life has been an imaginary number as well. If I say I've got 4 apples, technically what you have is 4 plus 0i apples. If you have 7 cars, it's 7 plus 0i. So every number can be written as an imaginary number. It would be the real number plus the imaginary component. So 5 plus 2i is an imaginary number. The imaginary component is the 2i. Now, do you have space underneath there? Yeah. Let's do this. We'll start off with this. I fourth, I fifth, I ninth. So now we're going to evaluate I to some different powers, and not a 0, 1, 2, 3. Now, when I look at the wheel of I, which is up here, keep this in mind. Notice that this sort of looks like a compass. Up top, I've got 1. What's opposite the 1? -1. To the right, I have I. What's opposite that? So they always are opposite. They're opposites. And furthermore, when I do this, it's cyclical. So I to the 4th power, well, you've got I to the 0, 1, 2, 3. I to the 4th would fall on top of I to the 0 power. And what's I to the 0 power's value? 1. So I to the 4th has a number value of 1. Does anybody want to take a guess as to what I to the 5th is going to be? Hands up, please, when you can tell me what I to the 5th you think is going to be. There you go. I to the 5th would be I. You could get that by counting around. Remember, your counting has to start at 0. So 0 is at the top, so is 4, and then 5 is one more. How about I to the 9th? Hands up, please, if you can tell me what I to the 9th would have as its value. You got 1, 2, 3. What do you want to say? I again. How about I to the 15th? Hands up, please, if you can tell me what I to the 15th is going to be. -I. Now, there's some of you that are going to notice and be able to answer this one really, really quickly. I to the 103rd power. Hands up, please, when you can tell me what I to the 103rd is going to be. Think about the spirit of the question. Think about what we know. How'd you get that? Now, she's absolutely right. I'll say it maybe a little bit more succinctly, or a little bit maybe more direct. What she recognized was this. Every 4 it repeats, right? So what multiple of 4 is near 103? Which one did you say you used? You said it was, I thought you said, walk us through how you got it again?
Yeah, I did.
And what's 4 times 25? 100. So she recognized that 100 is a multiple of 4. And then to get there, she counted 3 more times. Now, you could have also used, instead of using 100 as the multiple of 4 nearby, what other multiple of 4 could you have used? What someone said? 104, yeah. You could use 104. If you don't know that, you could use 96. You could use 80. You could use 88 and just keep counting around. Now, I always tell you this in caution. This always makes me laugh. On the test that when I teach this at U of R, one of the questions on there, and it's calculated for you, is evaluate I to the 137th power. Now, we teach them to draw the same wheel of I. You have 2 hours to take a test when you're in college. Most kids finish at about the hour mark. Very seldom do I have to stay the full 2 hours. Wow, it's wonderful. I remember sitting there, and there was somebody, and the room is structured similar to this. So I'm sitting at the desk, and all of a sudden I start hearing this. And literally, there was a young man right here, and I'm stopping, and I'm like, and I realized what's happening. And then there was a young lady sitting right here, who literally, while she's taking the test, I see this. Now, what were they doing? 137 times. Is that the spirit of the question? Now, it gets worse because later on, and now I'm sitting there realizing what's ahead for me. Because then there's a question later on in the test where it says 3. Normally, I would say that what this person did was wholly inappropriate. But they were sitting there, and to their defense, I know because I had to put up with it as well, they were literally pecking like a chicken, or a woodpecker, around that wheel. And around, let's say, the 400th time, the person leaned over, gave a breath, and then uttered some inappropriate obscenity as the person counted. A lot of the kids in class started laughing because they knew exactly why. Nobody wants to sit there and hear the chicken pecking for 507 times, followed up immediately by 109 times. Now I realize that they didn't look at the question well, because you figure on the way to 507, you'd stop and write down where you were at 109. But they didn't do that. They did 507 and then 109 again. And by the way, they miscounted and got both of them wrong to make it even more cruel. Now, is that the spirit of the question? No. It's finding the multiples of 4 that's the spirit of the question. So what's a multiple of 4 that's near 507? Well, I know 100 is a multiple of 4, so 500 is also. And then you could count 7 more around. Maybe you could see 504, but whatever. So do we get that piece of it? Let's hope. How about this? We know the square root of -1 now is I. We're going to list these out. Tell me what they think the square root of -4 is going to be. By the way, it's not going to be plus or minus because it's not part of an equation. Who can tell me what the square root of -4 is? We got 1. Really? Really? 2 of you? 3? Oh, you did what's the square root? 2i, yeah. 2i. How about the square root of -25? Hands up, please. Yes. 5i. How about the square root of -81? 9i. Now this is where it's going to be a little bit difficult. How about the square root of 8? How about the square root of 8? It's going to be shockingly similar. You all right now can handle what that is. We've got 1, 2, 3 of you. 4. Just 4 to 6. That's outstanding. It's the same except it's got an I in it. How about the square root of negative 32? Hands up, please, if you can tell me what the square root of negative 32 is going to go to. 1. You can use your calculator if you need to. If you need your perfect square, how? 2 of us? Don't stare at it. That doesn't make us better. 3 of us? 4? Close. You pick a perfect square, not the biggest one. 4i radical 2 because it's 16 times 2. How about for question, the next one, square root of negative 48? What's that? 4i what? 4i. There you go. It's exactly the same, except for the I part. And the square root of a negative sign is I. That's it. You all are so capable of doing this. Now, let's solve out for x. Let's watch how easy this becomes. Here's my question for number 2. And, Alexa, what would you do to start this off? How many answers am I going to get to this question? 2. Why? What kind of equation is it? How'd you know that? Perfect. So I'm going to subtract 18 from both sides, so that leaves me with 3x squared is equal to negative 12. What are we going to do next from here? Talia, what do you say? And you're left with? What are we going to do next? Noah?
Take the square root of 12 times.
And I'm going to get what is an answer? Abby? Who's going to yell right now? Who's going to scream with vengeance? You know? How many answers am I supposed to get for this? Plus or minus 2i, yeah. Remember, it's a quad equation, so you're going to be getting 2 answers. Let's go forward now and start simplifying some stuff out. Take a look at what's there for 3a. John Paul, which one of those radicals do you want to simplify down first? What's the square root of negative 25? Close. It's only positive. Because you're not getting it as part of an x squared equation. What's the other one going to be then? So now I've got 5i plus 7i. Those are like terms. What would I go through and get when we are solving this out? Nick?
12i.
Let's take a look at the b half. Ben, what do you get when you simplify down the square root of negative 8? 2i root 2 minus, what about the square root of negative 18? Anna, do you know what that would simplify down to? What are we going to do from here? Rob? So what are you going to be left with? Questions on that one? Now we're going to simplify these without a calculator. So hopefully this gets real easy for you. Let's say this. If you need it on this page, instead of going back and flipping back and forth, because you need to know what it is, remember it starts out, I to what power starts out up top? 0. Then I to the first, I to the second, and I to the third. What's I to the 0 power going to equal? Eli? 1. What's I to the first power going to equal? Erica? What about I squared? Leah? And then I to the third? Amanda? All right, now that we know that,
And we'll draw equals like those.
Take a look at what's there. What's I squared going to be the same as, Alex V?
-1.
What's I to the 40th going to be the same as? Hands up, please, if you can tell me what I to the 40th is going to be. Tim? What'd you say it with it? 1, yeah. Because remember, 40 is a multiple of 4. We've got to know our multiples of 4. What about 8 times I to the 82nd? Well, I need to know this is 8 times a number value. What's I to the 82nd going to equal? Hands up, please, when you can tell me. Think about a multiple of 4 that's nearby 82. We got 1, 2 of us, 3, 4, 5. What multiple of 4 did you use? 80. And then go 2 more, gets you to the -1. And now this is the tough part, 8 times -1. Thank you, it's not 7. Next one up, you've got -3 times. Now, 266. If you need to go through and use the calculator to help you find that multiple, go ahead and do it. But what multiple of 4 is near 266? 240. So keep counting around them. Or hunch for a closer one. Did anybody use a different one? 250 is not a multiple of 4. 260 is a multiple of 4. Did anybody use a different one? 264, did you say? Yeah. So what are we going to get for I to the 266? It doesn't matter what you use. I could care less. You got 1, 2, 3, 4. What do you say? Not negative I. I've got a different one. Yeah, it should be -1 because 264 falls up top. And this comes out to be a +3. Questions on that one? I to the 23rd, hands up. What about I to the 23rd? Hands up, please, if you can tell me what I to the 23rd is going to be. -I. Twelve times I to the 41st. Well, what's I to the 41st going to be the same as? Oh, come on. Come on. It's going to be an I. So this is 12 times I, which is? What about -8 times I to the 93rd? Hands up, please, when you can tell me what I to the 93rd is going to be. Find a multiple of 4. If you need to use the calculator to help you, that's fine. But don't wait for it to happen to you. Find a multiple that's nearby that's going to be helpful. We've got I to the 93rd. You said -I. Is that what we got? Isn't it? Oh, I forgot. Yeah, because 92 is a multiple of 4 and then one more. So that would be an I. So your answer would be -8I. Next one up, I to the 501st power. I think I might have even used this example before. What multiple of 4 is right near 501? Because you know one of the multiples, and that multiplicity continues on forever. We've got 1, 2 of you who see it. What multiple is nearby? 500 is, so 501 would be an I, so that would be 4I. Now, and again, I love this. We're using so much better language now than you've used before. Remember in the beginning of the year when you didn't know what a Cartesian plane is? Now we know what a Cartesian plane is. We know what a lattice point is, which is where it crosses at 2 points on the grid line, if that's how you need to define it. When it crosses at integer coefficients. So we know Cartesian plane, that's the xy plane. So we were saying before, well, can we just sort of make this up? Well, now we're not dealing in a real number system. Because we have a real number, and what's attached to every real number? An imaginary number. So we're going to have to go through and grab the Argand plane. The Argand plane is just a little bit different. It has this component here, which is an x-axis, This is a y-I axis. So when I give you a complex number to go through and graph in a plus bi form, what your task is going to be is to make sure you accurately locate this. And again, we'll have some very limited people who will try to tell you you graph it one way and you don't. Taking a look at what's here to start off, we've got 2 we're going to graph out. We've got negative 3 plus I. So if I'm graphing out negative 3 plus I, this is the x part and this is the y-I part. We're going to go to where both of those conditions are satisfied. The x has to be negative 3, So I go back 1, 2, 3, and the I is positive 1I, so I go up here. This point here would be negative 3 plus I. Now, this is where some people are a little bit asleep at the wheel. Imaginary numbers are all vectors, which means it's like a, you remember drawing out rays in Geo? Did you do that before? It's got a fixed, one end of the line is fixed, it's got a start point, it continues infinitely in a direction. That's what a vector is. It starts at the origin, and it's going to go through, and the only point that you're concerned that goes through is that one there. You'd make it nice and tight and neat. The arrow point needs to end at negative 3 plus I. By the way, hands up please when you tell me which quadrant this gets drawn out in. Fabulous. Seriously, we don't know which quadrant number this ends in? 2. Take a look please at the next one. 2 is it 2 or negative 2? 2 minus 5i. Hands up please when you can tell me which quad that's going to get plotted out in. 2 minus 5i. Come on. Terrific. I'm going to go over 2 and down 5. So I go over 1, 2, down 1, 2, 3, 4, 5. What didn't I do yet? To label this. Questions on that? Let's give these out in simplest form. Now, this is one where it's going to be a little bit frustrating from my end because it's an order of operations PEMDAS one. This is the stuff you guys should have done back over at Sprott. If I'm asking you to simplify this out, so we take off the quantity 5i to the 7th times 3i to the 81st times negative 2i. Who can tell me what I'd have to do first in order to get this simplified out? Yeah, let's raise the 5i to the 7th power. So now, go into your calculators, please. And by the way, make sure you... Oh, you're not able to sign in yet. Sorry, I'll make it so you can sign in a minute. What's 5 to the 7th power going to give you? Hands up, please. You can tell me whatever that number is. I think it's 6 digits. Yeah, do you have 78,100. 78,125. And then I to the 7th times 3i to the 81st times negative 2i to the 1st power. I'm going to write that in because most of you are going to fall on your face if we don't. Now I need to multiply those 3 things together, so I'm just going to multiply going across. I need to multiply my 3 coefficients together. Hands up, please, if you can tell me what I get when I take those 3 coefficients, which would be negative 6 times that 78,000 value. Can you go ahead and read it to me, please? Who's got what that number is going to end up being? 750. Now, we've got I to some power. What do you do to the exponents when you multiply with like bases? Add them. So who can tell me what the power on that is going to be? The I to what power? Yeah. Terrific. And what do you think a lot of you are going to fall asleep and forget to do? Add that I to the 1st at the end. Now, I to the 89, hands up please if you can tell me what that's the same as. Outstanding. Seriously? I to the 89 power, we don't know what that's going to be? We got 1, 2 of you, 3. Negative I. No, positive I, good. So this is negative 468,750 I. Questions on that? All right. Now, we'll do, oh, here's another one. Is this our last one? Yeah. All right, now, I need you to go through right now, and here's what we're going to do. We're going to divide up the work. This first row here, you need to tell me what I to the 488 power is going to be. Second row here, you guys are going to tell me I to the 113. Third row, you kids have I to the 227th power, and you guys here, go through and tell me what I to the 18th power is going to be. So hands up, please, when you have what this is going to simplify down to be. We got one person. Oh, come on, wake up. Two of us, three. So 488, that's going to be a 1, okay? What about 113? Comes out to be an I, okay? What about 227? Who in this row got 227? None of us? Negative I? And what about I to the 18th? So now I'm going to simplify and watch what happens. I've got 7 minus 3I minus 5I plus 6. What's that? Yeah, because it's negative 1 times that. Who can tell me what this is going to condense down to in 8 plus VI form? Go ahead. Now, there's one more thing I want to show you. And as of now, okay, now you can log into your calculator. I want to tell, and you need to make sure that we can see this out, I really need you all to understand this. So much of the stuff that they did with you, from what it sounds like before, was garbage that's going to get you through the Regents exam. And I'll show you every calculator trick under the book. In June, you have to know how to do the legitimate math, because, again, when you go on beyond this course, a lot of people, if you go through, even at MCC, any math class that you take prior to Calc 2, there's no calculus. You have one of those that'll kind of only work solely. Now, you have to know this, but I'm going to show you the calculator gimmick that you can use to check your answer, which is going to be this. Make sure, again, that you all go to a new document. So let's start off and go to a new document. Now, let's do this. Let's say you're doing this and you forget what your wheel of I looks like, but you know that you've got I to the 0 power. So what let's start off with is this. So go to Add Calculator, that's fine. Now, please press the pi button and select the I. I caret 0. Hands up. Now go through I raised to the 0 power. What value is that going to give you? 1. What about I to the 3rd power? Go in and input that. I caret 3. Negative I. Now, let's type in what we did for the one before. Parentheses, 5I to whatever that was. To the 7th, I think it was. And keep going. Whatever that last example that we did was, times, or keep going, that's good, 3. Oh, careful, we did E. Press enter. Is that what we got? Yes or no? Now, all this does is it makes it so you have legitimately no excuses, none, to miss this on a test or a quiz. Okay? Actually, no excuses. Now, coming back to you all now, we're going to have you start handing back your, there's a bunch of assessments and tests to go through and hand back. We'll say that I'll tell all of you the same thing that I told the others. Some of the tests were outstanding and some of them weren't. And no, we don't do test corrections, but instead I'll tell you this, which is an even better incentive than a test. Number 1, as of tomorrow, if there's any tests that were less than a 60, we bumped the floor grade up to a 60. Okay, so if you got a 40%, we'll change it to whatever percentage goes in as a 60. That way it's not debilitating. But at the same time, here's the thing that I'll tell all of you. Instead of going through and doing some garbage test corrections, which overinflate your grades ridiculously, I'll tell you this. If we get to, the end of the quarter, and you had one bad test, and it's a complete outlier, meaning you are pulling 90s or 80s instead of that one grade of a 60 or a 70, that's what we do. We omit it. We don't do test corrections. You don't go through and arbitrarily say, well, I didn't know, so I'll make up the points later. I'll tell you, show me that it's an outlier. Meaning, show me that you've had growth. And we'll omit it. It's that easy. We'll just go, it takes one right click. I go, yeah, drop the lowest grade. It's done. But you have to make sure that you show me that that's the case. If there's any of them at all that you want to see gone over, we can go through and do it. And I'll message out to you by the end of the period today what your homework, what the answer key to the test is. Do you want the answers to tomorrow's homework? Yes? All right. Oh, do we have a copy open? 2-5. Here you go. Here's the answers to the homework that you've got for tonight. What do you have waiting for you when you come in next time we have class? Quiz. Now, this will be up for the rest of the time. If you need to take a picture of it, that's fine. Can you set it in the bin, please, that says Enriched 3?